Hey everybody, this is Rick. I'm going to talk about lab 11 here. This is our solidity lab. Now what is solidity? When these two, if you look at these two wind turbines here, this one has high solidity, this one has low solidity. And there are different advantages of each, mostly being torque, which is a twisting or turning force, and power. You're exchanging torque for power. Basically, how much can you lift or how much force can you twist versus how much power can you generate. You have to understand two concepts to understand solidity. One is the planform area, and one is the, I'm trying to find a blade here for you. I'll just use this as an example of a blade. So if this is a blade, this is the area that you'd see of a part here. Let's see. And so of a turbine, if you turn different angles, like here at 90 degrees, it just has a very low area, and the maximum area is at 0 degrees. In 45, it's about halfway between. So one of the things we're going to do is that's the planform area. The swept area, if you see in this graph here, is the area of that the rotors sweep out that face the wind. So it's just pi r squared. That is just the area. It's the radius time pi times the radius squared. The solidity is the number of blades times the swept area. The planform area of each blade. That's n times a divided by a, the swept area. So that's the solidity, and the solidity is indicative of how much torque or power you're going to get. On this graph here, your lab will probably say meters, but this should say centimeters for all your measurements. And what we're going to do is try some numbers of blades. Now we won't be able to do 5. I was supposed to be a surprise for you guys to figure out on your own, but there's no way to space out 5 blades evenly in this test. And we're going to get the amount of power. And what I did was calculate the planform area for you. So what I did was I took some photos of the blades at different angles of inclination. Then I filled them with a red color, and then I counted how many red pixels there were. The first one was the most, and then I had fewer and fewer as we turned it. See how it's fewer red pixels here. So I have to click that area to get the number of pixels in that area, and that's what you do, and you get it here in this histogram, and you can count them. So that's what I did, and I put those values in this graph in this Excel spreadsheet. And so I knew that this one with 284,726 pixels was 21 square inches, because I knew that was 7 times 3, and then everything else is a proportion of that. The 30-degree angle is 227,341, and so it was the same as the ratio of this divided by that times this, and so that's how I got these values. These are the planform areas. You don't have to be able to calculate it. I'm giving it to you. If we were in class, I would have you take a picture and do this with Photoshop. The swept area is just that times the number of the swept area is just the pi times the r squared. So the radius was 8.5 inches across the whole set of blades, the turbine. Convert that to centimeters is times 2.54, and so 3.14 times the radius squared is this many, and that's this number down here. That's the swept area. The planform area is just the individual area, in this case 30 degrees, times the number of blades. And then I have a little graph here that shows the planform area. You don't need this, just for fun to see that as it goes down. And then, so what we're going to do in our lab today is I am going to give you different numbers of blades at 30 degrees. We're going to do 2, 3, 4, and 6 because 5 doesn't work. And I have the values for you, already written down. So the values are, spoiler alert, I already did this. It's 74, 101. Then it was 55 and 30. And this one we didn't get. So those are the values we're going to have, and I'll let you watch me take that data, and then we'll come back and we'll do a little analysis. I hope you enjoy it. I apologize, but my computer wasn't working well, and I didn't realize my voice wasn't being recorded during this part. So you can imagine this is me taking the data, and also it sort of stopped, the device sort of stopped communicating with my computer later. So I wasn't really tracking the data on screen, so this part might not be all that useful to you. You might want to skip up to a later time if you want to just see the end of the video. I really apologize that that was the case. But you can watch it and you get the idea, and I'll give you the data results at the end. Now that I've done the rest of the editing, I can comfortably tell you to skip ahead to 8 minutes if you want to see the rest of this video. All right, so what do we got? We got our data here. We have the solidity, which we already know. I'll give you the start. We don't already know. We'll get it in a moment. We have the power, and we have the solidity. So let's look at the number of blades, the planform area per blade, and we have the total planform area. So it's just going to be, we're just going to take this data here, and we are going to make a spreadsheet out of it, and we're going to calculate all of this stuff. So I'm just going to go ahead and copy this over to Excel, and I'm going to make a new sheet right here, and I'm going to make it a little larger so you can see it. And I'm just going to take this. This is the total planform area is equal to this times that. That's that, and we didn't do 5, so we're 1 short. Then the swept area, which we get from our other sheet, which is going to, I'm just going to say, is equal to this one, and then we'll just drag that down. And then I'm going to say the solidity, which is equal to the total planform area divided by the swept area. That's the solidity. And the number of blades versus the solidity is something that we can, if we so choose, we can plot here. And there you go, no surprise, it's linear, so the solidity goes up as the number of blades go up. The power that we had, if we weren't interested in seeing the power with the solidity, which might be of interest to us, I will put, I will merge these two cells here, if it will let me. There we go. I will put power here, So power versus solidity would be interesting. So let's look at the previous page here. We had, actually we'll get that from our, I don't think you're required to turn this in. It's 74, 101, 55, and 30. And so there's a maximum, right? This is a little surprising because now there's a maximum. So we're going to go insert, plot, and then it goes like this. So the power, there's a best solidity for power, in other words. So that's kind of interesting to see. And that's it. That's that part of it. So back in this other table here, we had these numbers here, the solidity. I would copy those and just put them, you can put those values in here. There are 0.15, 0.221, 0.295, and 0.442443, and 0.147 for this part. Yeah, you get it. And because the swept area is always the same of 1463, and you have the total planform areas as per the other part. And then the questions are, you don't have to do this part, right? So because we're not doing that, you're not doing the work I am, so you don't do it. We already did the Logger Pro photo stuff. So these are all things that I already did for you. I got the area. The questions here are, you calculate the swept area. Like I said, just do your answer here. This is the same thing I did. You can do it on the spreadsheet, and you can paste it, or you can do it manually. Examine your power and solidity data. How does solidity affect power? Make a graph. That's this guy right here. Then examine let's see, and then you don't have to do the. You don't have to do the extensions, but you need to do this part, which is, and then you're going to have to answer this on your own. It says, what if the turbine is instead performing work such as lifting a weight? Well, then you would want more solidity, and you would want to optimize. Sorry, you would want to optimize torque instead of power, which is affected differently. Power has a different peak, than torque would. And that's all you need to say, is that it's different. It's not the same. Your answer here is it is not the same. So that's what you do. I hope this helps. If you have any questions, please post them, and I'll help out as best I can. Take care. Bye-bye.